Definition: the branch of chemistry which deals with the study of relationship between electrical energy and chemical energy and interconversion of one form of energy into another is called electrochemistry. Large number of chemical transformations and industrial processes are based on electrochemistry. For example, extraction of reactive metals, purification of metals, and electroplating of metals. Electrochemical cell, a device in which chemical energy is converted into electrical energy, is called an electrochemical cell or a galvanic cell or a voltaic cell. In an electrochemical cell, a spontaneous redox reaction is carried out in an indirect manner, and decrease in free energy during the spontaneous chemical process appears as electrical energy. Construction: a zinc rod is dipped in a ZnSO4 solution and copper rod is dipped in a CuSO4 solution taken into two separate beakers. Zinc and copper rods, which act as electrode, are connected by a conducting wire through a voltmeter. The two electrolyte solutions are connected through a salt bridge. It is an inverted glass U-tube filled with a warm concentrated solution of some electrolyte. Working of electrochemical cell. Oxidation. As zinc rod loses weight, zinc solid must have gone into solution. Zinc metal does not dissolve as such in aqueous solution. Therefore, it must have been converted into zinc ions. Zinc undergoes oxidation into zinc ions. Reduction. A film of copper solid is deposited on the copper rod. That means copper ions present in solution must have been converted into copper solid. Copper ions undergo reduction into copper solid. By convention, the electrode at which oxidation takes place is called anode, and that electrode at which reduction takes place is called cathode. In this electrochemical cell, zinc rod is anode and copper rod is cathode. Observations in electrochemical cell. Voltmeter shows a deflection with a reading of 1.10 volt, which indicates that a potential difference is set up between the two electrodes and conventional current is flowing through the circuit from copper to zinc rod. After some time, a film of copper is deposited on copper rod. The zinc rod is found to have lost weight. Significance of salt bridge. Salt bridge allows the flow of current by completing the circuit. It allows the flow of ions but does not allow the flow of solutions. Salt bridge restores electrical neutrality of electrolytic solutions. The anions of the electrolyte in the salt bridge pass into anodic solution and cations of the electrolyte in the salt bridge pass into cathodic solution to maintain electrical neutrality. Thus, a salt bridge prevents accumulation of charges and maintains the flow of current in the circuit. Representation of an electrochemical cell. An electrochemical cell or a galvanic cell is represented in a manner as follows. Salt bridge is represented by two vertical lines. Single vertical line represents the phase boundary between the electrode and electrolyte. Anode is written on the left-hand side of the salt bridge. It is written as the symbol of the metal followed by the symbol of the ion with which it is in equilibrium. Cathode is written on the right-hand side of the salt bridge. It is written as the symbol of ion first, followed by the symbol of metal with which it is in equilibrium. Electrode potential. The electrical potential difference set up between the metal and its ions in the solutions is called electrode potential. When a strip of metal is brought in contact with a solution containing its own ions, then there is a possibility of either of three processes taking place. Metal ion may collide with the metallic strip and bounce back without any change. Metal atom on the surface of strip may lose N electrons and enter the solution as ions. Metal ions may collide with the metal strip and gain N electrons and get converted into metal atom. EMF of the cell. Any galvanic cell is a combination of two half cells, and electrodes in these half cells have different electrode potentials. The difference in electrode potentials of the two electrodes of cell is termed as electromotive force of the cell. Steps to calculate EMF of the cell are: obtain reduction potential for the anode and reduction potential of the cathode. Combine the two reduction potentials. EMF of the cell is equal to reduction potential of cathode minus reduction potential of anode. That is, E cell is equal to E cathode minus E anode, or E cell is equal to E right minus E left.